Thank you all for coming today and for watching this. If you're watching this on YouTube, I am Janessa Peterson. I do marketing here at Smallstep. Previous to this, I was deep in the PKI and infrastructure world at the open and free CA Let's Encrypt. And before that, I worked at a Linux distro and container orchestration company called CoreOS. I'm here today with Jay Hunter Hawke. I will probably call him Hunter in this conversation. He's a security solutions architect here at Smallstep, and we're here today to chat about how he came to find Smallstep as a solution for his PKI needs at his previous company. Hunter, would you like to take a moment to introduce yourself and tell everyone a little bit about you?
Sure thing. So I'm Hunter Hawke. The J is just there to let you know that's not my first name. I'm a dog owner. I love to travel. I spent the last school year with my wife in France while she worked there as a teacher. And I hear that I make a mean grilled cheese in my free time. Previously, I was the information security architect at KCF Technologies, an industrial IoT company based out of State College, Pennsylvania. That was one of my first jobs, being a Penn State alum based out of State College. While I was there, I worked on the security team, all the work including PKI primarily. But overall, I was responsible for the security policy, training, implementation, and for a time, privacy compliance for the company.
Awesome. So, Hunter, you recently documented your journey in finding Smallstep. Before we took Hunter on at Smallstep, he was at KCF and doing all this work, and recently detailed his journey in a blog post. You were specifically working with open source Step CA and Step CLI with KCF. And also, anyone watching this, you can check out that blog post. I'll drop a link in the chat. So kind of tell us, give us a synopsis of this blog post. What were the requirements you needed for this project at KCF Technologies? And can you tell us a little bit more about that journey?
Yeah, sure thing. So this entire project started when my manager at the time came to my desk and mentioned that our hardware team was in the process of creating a new generation of hardware devices. We called them the Base Station V4. I believe they were ultimately marketed as Base Station Next. They were supposed to be leaner, slimmer, more powerful, smaller, and nearly impenetrable, like much more secure than the previous model, because we were trying to get into more government facilities. We were trying to get into more lockdown environments. We needed something really resilient that was absolutely bulletproof. So that path led me on a bit of a search, because we were used to using passwords at the time. We considered setting up a password database, but that would be a nightmare. And we figured at that point, we might as well set up our own PKI and manage it in-house. So I went on a bit of a journey evaluating different vendors. Since we had so many devices out in the field that needed to be so slim and resilient, we needed something that could just generate certificates on a whim. So we couldn't afford our Smallstep's costly competitors, who would charge somewhere around $18 to $20 per certificate generated. Yeah, not fun. And we didn't want to use a public CA like Let's Encrypt. So I started to look for open source projects instead. And that way our budget was just the resources we used and my time spent on the project. Through that, I found a numerous slew of projects on GitHub. However, ultimately, I found that the Step CA and the Step CLI were by far, in my opinion, the best, and especially the best for my use case at the time.
Recognizing a little bit of bias there now, right? Now that you're on the team here, but
Honestly,
back then, yeah, you were totally new to it and just doing vendor, just checking out all the different vendors. That's really cool. So you had mentioned not wanting to use passwords, and dealing with a password database, or from there, I'm assuming secrets. So they are typically the de facto means of security. So what made them cumbersome for your environment? And if you could tell us more about the difference in security between certificates and passwords.
So the challenge was ultimately we were securing IoT devices in the field. And we had at its core, two different devices that we would sell. We would sell sensors, which would sit in the field and communicate amongst themselves, and then proxy all of their connections back to what we called a base station, which was a Linux box sitting somewhere secured in the facility that would take all that data, store it locally, and then burst it up to our cloud so that our software can do its data analytics on it. Securing those connections with passwords was fine because we had to tie back to that device via that password, but it becomes difficult to manage. If you have 5,000 devices, there's 5,000 passwords right there. And then it's a best practice to update those passwords regularly, whether it be once every 2 years, once every year, monthly, depending on your policy. That's insanely cumbersome. Do you log into the device? Do you have to SSH down to it and physically change the password? Can you do that via your hardware? We use Hawke as hardware management. Would we do that via our hardware management platform? It wasn't easy. It wasn't simple. It wasn't straightforward. It was just a lot of work. Additionally, they weren't as secure as certificates. Effectively, we decided to go forward with certificates because, one, they're really easy to renew and rotate. And two, once we got all of the devices to trust our root CA, we could use them to implicitly trust all of our systems. So think of it as a password. Think of a password being a nice security tool, be it difficult to rotate. However, certificates were much bigger, much more secure, have a lot more, have massive key sizes compared to passwords used to encrypt data. And then you could also fill them with metadata about the device, so we would be able to know absolutely everything about the device we were connected to, separate from anything else, just by the connection, just by the certificate we were connecting to. That's something you lose with a password.
Yeah, definitely. We also at Smallstep we have both active and passive revocation as part of Smallstep Certificate Manager. Um, Tell me a little bit more, like if you can explain, active and passive revocation, and also how would active revocation of a certificate help to secure your industrial IoT environments?
Yeah. So for the longest time there, we only utilized passive revocation. The difference there being with passive revocation, you generate a certificate and then say you revoke it. Once the time comes to renew the certificate, you cannot. The certificate will die at its lifetime, unable to be renewed. However, it can still be used up until that point. So our best practice was really short-lived certificates, as short as your threat model, as short as your environment would allow you to let them live. And then when you revoke them, they die off a really short time later. Whereas with active revocation, we use certificate revocation lists and OCSP responders to track what certificates have been revoked, and any devices using the certificate will first check the revocation list, check the OCSP responder to see if the certificate was revoked. If it wasn't, it can be used. If it was revoked, it's dead on the spot. So with active revocation, you can kill off a certificate instantaneously, whereas with passive revocation, the certificate lifetime will last until it expires. Yeah.
Yeah, that sounds great. And also with Small Step Certificate Manager, you can renew after, right? Renew after a certificate has expired. Can you talk a little bit more about that and how especially that would be helpful within IoT?
Yes. One of the biggest problems we ran into was, what do you do with a device that is sitting on a shelf for an extended period of time? Because at that time we only had passive revocation. Um, we wanted to have short-lived certificates on these devices, but say you generated a certificate that lived for a month, the certificate's loaded onto the device sits on a shelf for 2 months. Well, that's a dead device. It can't communicate to the cloud. The certificates cannot be renewed because, again, with passive revocation, once it expires or once it's revoked, you can't renew it. We didn't have we didn't have renew after expiry at the time, which would have really been a huge help to me and probably would have made this project a little easier on myself. So we had to go with longer lived certificates that would live for years at a time, and then we would use those with an X5C provisioner or some other authentication scheme to authenticate the actual device certificates. Renew after expiry would allow you to generate these month-long lived certificates, and then they could expire. However, you can enable renew after expiry on a provisioner, and that device could still reach up, talk to the provisioner, say, hey, I know this is expired. Can you still renew it anyway? Provisioner will renew it, return their certificate, and then there's your device still active.
I love that idea. And so, if things aren't flying off the shelves, if your hardware isn't flying off the shelves, you can still correspond with it when it does finally get into the hands of the user.
Exactly.
So obviously you're here, at Small Step. After this experience, you started working at Small Step. What are some of the other features that you've brought in, from your experience that you've brought into Small Step that you're like, I wish I would have had this back when I was creating this PKI for KCF.
There's a few different features. And honestly, some of them are with the paid product. First of which would be active revocation, which we have with the paid product. It's a lot harder to do with open source, while it is technically possible to hack together a solution. Renew after expiry was by far the biggest one overall, because that would have solved the issue of presented by short-lived certificates with passive revocation. We had to make a couple adjustments to the security model. We had to add some compensating controls. We had to add a little bit more monitoring because we didn't have renew after expiry. We had to have long-lived certificates, and we had to mitigate whatever threat well, not threat, but whatever that introduced into the environment. We had to take that into account. Likewise, I'd say a big one is remote management. Our engineering and open source contributors have released a feature back when we got rid of the beta commands, called remote management, which would take provisioners and provisioner settings, and instead of storing them in the ca.json file used to define the step ca settings, it would store it in the Badger database instead. That would have been a huge win for me, because at the time when I set this up, that didn't exist. Provisioners and all settings were in ca.json, and I had an auto scaling cluster of VMs. So the state of the ca.json across those had to be the same all of the time. And if I could have removed that piece and put it in the external database that I used, I wouldn't have had to write a couple lambdas. I wouldn't have to build a couple integrations. It just would have been there and taken care of for me.
I love that. Like, I love the simplicity. Like, you had all of this experience, and then you came to Small Step, and you're like, I need to make this better. I need to make this simpler. Like, and working with the team to do that has been really cool, really awesome to see.
Yes, they've really solved a lot of those problems that I faced.
Yeah. And in this experience too, and then coming to work at Small Step, how you're a solutions architect, a security solutions architect. You are working with customers on a daily basis to help them with their own internal PKI and Small Step as a solution. So how does your experience at KCF and being one of those users really help with your interactions with Small Step customers or potential Small Step customers today?
So at the core of things, I think I have a lot more empathy for our customers, knowing that if you don't have an extensive background in PKI or security in general, you're kind of coming into this space a little bit blind. I know I harped a lot in the blog post about how hard it was to build out the infrastructure, how hard it was to maintain the infrastructure, the overhead it introduced, how I kept getting pulled in different directions all of a sudden. None of that was the hardest part. The hardest part was getting up to speed on PKI and trying to figure out what I don't know. There was a lot of factors involved in here, where there were same defaults that the open source had, but that didn't quite fit our use case, that I had to work around. And then I would find later on that there's this other piece of PKI that I should have taken into effect. It won't quite scale that way. Oh, something would come up later. I didn't know this about PKI. It doesn't quite scale that way. And I should have taken that stuff into my design considerations. So being an open source user first before working here, I tend to see the same with our new clients who don't have the background like I didn't have. It's a bit of a mountain to climb. There's a lot of documentation that we have. There's a lot to learn. But once you get through that process, and if you have somebody like my team members to assist you through that process, what took me ages to do could probably take our customers a week. Just to get up to speed, have somebody to talk to with your same defaults. And I find that since I was such a regular user of it, I am also seeing particular use cases that I had where I'm able to help our customers with suggestions. So in terms of templating, in terms of provisioner settings, in terms of how you structure your CA hierarchy, I've already had to come up with those with previous projects, and I've noticed patterns across our existing customers, across our paid product, where a lot of people could just use somebody to guide them in the right direction, point out a couple things they might not know, and basically just act as a guiding hand through this process, because it is hard.
Yeah, one of the things that I've loved, to see from our team and to see from Carl, who is our off-road engineer here at Small Step, is the amazing documentation and tutorials that comes out of every
Mm,
conversation, right? Like even conversations we're having on Discord with open source users to conversations we're having with customers. Small Step is so huge and such a base of, everything that we do within software, within IoT, really any vertical, right?
mhm,
Like PKI is such a base and a core thing, and you can do so much with small step that it's so cool to see, like, oh yeah, like well, yeah, somebody was like, yeah, I need to secure my Kubernetes ingresses. And we're like, oh,
mhm,
we can do that. It's just it's so cool to see how many different places you
mhm.
can really use small step. It's a very neat thing. So if anybody has any questions, you feel free to put them in the chat. If you're watching this on YouTube, feel free to schedule a demo and come talk with us and ask questions there as well, with Hunter and the team here at Small Steps. So I'll put those links in the description and also in the chat as well. So if any questions, feel free to put them in. If you have questions about open source, we also have a Discord server. I'll also put the links up for that as well. So, Hunter, what are some other things you wish you had during this experience? You had Carl. So you had our off-road engineer, but what are features, we already talked about those, but what are some other things that you would have wished you had while you were getting introduced to PKI and having to take this on at your company?
Well, I know you just mentioned I had Carl. I kind of had Carl in little snippets. If I could have had a dedicated Carl, that would have helped immensely. That would have solved a lot of the problems we were having before the hours of troubleshooting. And honestly, we could have used a little bit of peace of mind with speaking with somebody who lives in PKI and works with encryption systems every single day. Um, Aside from that, looking at the product, Certificate Manager has a really rich library of different features that our open source doesn't have. Just starting from the top of my mind, we had trouble with logging. I used AWS CloudWatch just to export all of my CA logs, but that was a jumbled mess. We got everything from warning level up to error and then the certificate stuff was just kind of in the middle there. And if you're not familiar with AWS Logs Explorer, it's not the best thing to query. So we had a whole process of exporting those logs, digging through them through like the Kibana Elasticsearch stat. It was a lot of pain just getting to a point where we can get decent logs that we can troubleshoot with out of the system that we could see. Um, Certificate Manager has logging that you can just check there, which I particularly am a huge fan of. Um,
Yeah.
Outside of that, it has a great certificate view. A difference between our open source and our paid product is that our open source, the backend databases are a key value pair,
Mhm.
which is good enough to work, but it created a couple projects on my backlog where I wanted to create a crawler that would go through, export all of these different certificates, decode them, pull the different certificate details out, and put them in a database. Um, our
Yeah.
system here internally is relational. So it has all that data pulled out, and that allows us to give you a great certificate view where we break down every certificate that's been generated, its revocation status, when it needs to be renewed, all of its details, and you can just track all of your certificates in the dashboard. That was an insight that I didn't have, that I wanted, and that I just could not have until I went through and broke down all of that data by hand, which I never did get around to before I started here at Small Step. Um, but that's in my opinion, that's one of the strongest points of our software. Outside of that, we had some issues with hardware just trying to track the certificates and the state of any given certificate at a time. So we had to write a telemetry service that would communicate with the devices, check the certificates on them, check when they needed to be renewed, make sure everything's running fine. Whereas here, they're with Certificate Manager, you can sign up for emails, you can set up webhooks just to be alerted whenever there are any issues with your certificates. If one needs your attention, our systems can alert you ahead of time.
Yeah. Oh, this one's having trouble with renewal. Okay, let me go in and see what's going
Mhm.
on kind of a thing. Yeah,
And
and I love that we are also putting up a video on our YouTube as well if you haven't checked it out yet, about the search and filter feature
Mm,
within Smallstep Certificate
really
Manager, which is huge, when you're trying to figure out where, like, a certain subset of devices are in the field, where are the certificates at for those? So yeah, it's definitely a lot more. And we also have a great support team
mm,
led by our very own Linda Brown, who is incredible. That is, at our customers beck and call really now, which we didn't have when Hunter was setting this up. So that is a huge difference as well. Just having somebody be like, I can call them, and I can figure out what's going on with this. Yeah, nobody wants to be a PKI expert. Nobody wants to have to do that,
yeah.
um, except for us. We're the oddballs out over here, right? So we're happy to do that for you. Linda's team is happy to do that for our customers too. Um, so any, out of this whole journey, out of this, becoming a PKI expert really through this journey, what were some big surprises that came out of it?
Honestly, the biggest one was securing SSH authentication. That wasn't even in the scope of this project. We were just securing connections back to our cloud and back to our support platform via X509 certificates. I never heard of SSH certificates before working on this project. We use SSH keys, SSH passwords. And again, as I discussed in the blog post, neither is particularly ideal. You end up having to manage key. You're going to have to manage key rotation. You're going to have to manage password rotation. It's not fun. SSH certificates really took a lot of the pain out of this because all of our systems trusted our root CA, and therefore all of our systems could just get SSH certificates. It was beautiful. And likewise, all of our developers would have short-lived short-lived user SSH certificates that we can tie via OIDC against our identity provider. So we were able to set up SSO for SSH, which was a massive win for my team. And honestly, I kind of wish SSH Professional was a little more built out back then, because a lot of the problems I face with SSH, as I've lamented on, and Carl has asked I cut, and there was a lot more that Carl asked I cut out of the blog, because it was so extensive that I could have prevented just using SSH Professional if it had been a little more feature rich at the time. So that was one of our biggest surprises. The other one was simply how easy Smallstep products are to use. And when I say products, I mean like the step toolchain. The step CLI became a de facto replacement for OpenSSL in my work, and eventually all of my colleagues' work. Anytime they needed to work with certificates, they switched to step. It just took over in the cloud department, took over in the hardware department. That was another huge win for everybody.
I love hearing that. I love it. I think, the SSH conversation, that would be a totally other conversation. We've hardly touched on to our SSH Pro product. And the joys that comes with that. I always tell folks that, like, if you're not using SSH certificates, you either didn't know you need them or they're a pain in the butt to do.
Yeah.
So, we at least, my job as marketing, get that in front of people to know that they need SSH certificates, and then Smallstep's job is to make that easy. So we could, wow, that'd be really fun. That second half of that blog post really was really deep and gritty. But we have a tendency to overextend our blog posts, so we're trying trying to make them into a shorter read. But that would be an amazing conversation as well.
Yeah.
So thank you, Hunter, for sharing your journey with us. I really appreciate it. I know our community appreciates all of your work too that you've done to make Smallstep easier to use, and all the work that you do in open source as well. Um, I'm happy to work alongside you to bring the best PKI to our customers here at Smallstep. I know we'll be seeing you again soon, in February 9th, as we walk through securing Kubernetes and exposed services. So that'll be a fun webinar. We're going to be joined by our own engineer, Andrew Reed, and talking about Kubernetes ingresses and securing Kubernetes. So if you want to get started with Smallstep and securing your IoT or IIoT devices, you can click the link in the chat of this webinar and in the description of the video. I'll also send it out after to all of your emails after this webinar. And if you want to set a time to demo with us and talk to us and figure out how a small step really can bolster your security at your organization or even in your home lab, I'll send out a link to that as well. So zero trust starts here with Small Steps PKI solutions. Thank you all for attending. Thank you, Hunter, for joining us and being able to be in conversation with us today. And we'll see you all again soon, February 9th.
Thanks, Janessa.